NENOMATICA, where mathematics meets YouTube excellence. Welcome! In this lesson, we will discuss how to solve first-degree linear inequalities. We will handle the 4 basic forms and a special case. First, let's display the example header and the problem banner. Quick challenge. Before we start, try to recall what happens to an inequality when we divide by a negative number. Step 1. We use the solve linear inequality rule. Then we isolate x for ax plus b greater than 0. If it is positive, the inequality direction stays the same. If a is negative, the inequality reverses. Step 2. Apply the rule for greater than or equal to. Again, consider the sign of a for the direction. Step 3. Apply the less than rule. Write the interval considering the sign of a. Step 4. Apply the less than or equal to rule. List the intervals for each sign of a. Special case. If it equals 0, the inequality no longer depends on x. When b is non-negative, the statement is always true. The solution is all real numbers. When b is negative, the statement is always false. The solution set is empty. The statement is always true. The solution is all real numbers. When b is negative, the statement is always false. The solution set is empty. We will process the inequality exactly as laid out in the algorithm on screen, following each step in order. First, display the word example and the problem statement. Step 1. Rearrange the inequality. We'll add x to both sides and subtract 1 from both sides. Step 2. Factor out x, because both terms on the left contain x. Step 3. Divide both sides by m squared plus 1. Since m squared plus 1 is strictly positive, the inequality direction does not change. Step 4. Analyze cases for m. Consider the case m minus 1 equals 0 and the case m minus 1 not equal to 0. Final result. The solution set is the interval from the fraction m minus 1 over m squared plus 1 to infinity, open at the left. Summary time. We rearranged, factored, divided by a positive quantity, performed a precise case analysis, and stated the solution, open at the left. We will process the given inequality exactly as written in the image, performing optical character recognition, normalization, and then solving step by step with strict case analysis. First, we display the example and the normalized problem statement. Step 1, OCR and text extraction. We list the core formula we will solve. Step 2, expand both sides using the distributive property. Step 3, collect like terms. Move x terms to the left and constants to the right. Step 4, factor out x on the left and factor the right-hand side into a difference of squares. Step 5, factor the quadratic m squared plus 5m plus 6 into m plus 2 times m plus 3. Step 6, perform a careful case split by the sign of m plus 2 before dividing. We will consider 3 main cases: m plus 2 positive, 0, and negative. Case A, m plus 2 greater than 0, that is m greater than negative 2. Divide both sides by the positive factor m plus 2. The direction of the inequality stays the same. Case B, m plus 2 equals 0, so m equals negative 2. Both sides of the inequality are 0, giving 0 less than or equal to 0. Therefore, every real x satisfies the inequality. Case C, m plus 2 less than 0, which means m is less than negative 2. Dividing by the negative factor flips the inequality direction. We get m plus 3, x greater than or equal to m minus 2. Now split according to the sign of m plus 3. Here is the complete piecewise solution for all real parameters m, summarizing the domain of solutions for x. In this guided example, we will solve a parameter inequality step by step, following a clear rule-based structure. First, let's put the problem on screen. Quick challenge. Which terms would you move first to one side? Step 1. Rearrange the inequality and factor common terms. We subtract 2m squared x from both sides and subtract m squared from both sides, then factor progressively. Step 2. Analyze parameter cases. Because m is a parameter, we split into m equals 0 and m not equal to 0. When m equals 0, both sides become 0 and the strict inequality fails. When m is not 0, we can safely divide by m squared, which is positive, obtaining a simpler inequality in terms of m minus 1. Can you predict what happens depending on the sign of m minus 1? Step 3. Solve for x depending on the sign of m minus 1. If m minus 1 is positive, we divide by a positive number and keep the inequality direction. If m minus 1 is negative, we divide by a negative number and flip the inequality direction. If m equals 1, the inequality reduces to 0 greater than 0, which is false. We can summarize the complete solution set as follows. Summary. We rearranged and factored the inequality, performed a clean case analysis on the parameter m, observed that dividing by m squared is safe when m is not 0, and that the sign of m minus 1 determines the direction of the final inequality in x. Quick challenge. What interval for x would you get if m equals -1/2? Take a moment, decide the sign of m minus 1, and predict the answer. We will solve a parameter inequality exactly following the steps shown in the input image, correcting only where necessary. This is a full, case-based walkthrough. Step 1. Move all x terms to the left and constants to the right. Step 2. Factor out x from the left side. Step 3. Recognize a difference of squares and also rewrite the right-hand side as a factor of 2m plus 1. Step 4. First case, 2m plus 1 is positive, that is m greater than -1/2. Since we divide by a positive number, the inequality direction stays the same. Now we must consider the sign of 2m minus 1. This is the missing correction. Subcase A, m greater than 1/2, so 2m minus 1 is positive. Subcase B, m equals 1/2, 2m minus 1 equals 0. Subcase C, -1/2 less than m less than 1/2, so 2m minus 1 is negative. Step 5. Now, the boundary case 2m plus 1 equals 0. That means m equals -1/2. Then the left-hand side vanishes, and the right-hand side is also 0. The inequality holds for every x. Step 6. Final case, 2m plus 1 is negative. That is m less than -1/2. Dividing the inequality by a negative number flips the direction. Since 2m minus 1 is also negative here, dividing once more flips back to greater or equal. Here is the consolidated piecewise answer. The order and course steps match the input image, with the necessary correction of splitting on the sign of 2m minus 1 in the first case. Summary. We rearranged the inequality, factored, and then split by the signs of 2m plus 1 and 2m minus 1. Correct handling of sign when dividing inequalities was the only necessary correction to the image. Practice by creating your own parameter values and verifying the interval you obtain. Welcome! In this example, we will solve a parameter inequality step by step, exactly mirroring a structured algorithm. Step 1. Expand using the distributive property. Read it aloud as m squared times the quantity x minus 1 minus m is greater than x minus 2. Step 2. Move all x terms to the left and constants to the right by subtracting x from both sides. Step 3. Factor out x on the left. Step 4. Factor the expressions. Use difference of squares for m squared minus 1, and factor the quadratic on the right. Step 5. This inequality has a factor m minus 1 on both sides. We must consider the sign of m minus 1 before dividing. Case A. If m is greater than 1, then m minus 1 is positive. The inequality keeps its direction after division. Then, because m plus 1 is also positive, we can divide again to isolate x. Also positive, we can divide again to isolate x. Case B. If m is less than 1, then m minus 1 is negative, and the inequality reverses. When dividing, we get left side, m plus 1 times x less than m plus 2. Now split by the sign of m plus 1. Subcase B1. If -1 is less than m and m is less than 1, then m plus 1 is positive, so the inequality direction stays. Subcase B2. If m is less than -1, then m plus 1 is negative, so the inequality reverses. Edge checks. When m plus 1 equals 0, that is m equals -1, the inequality becomes 0 times x is less than 1, which is always true for every x. When m minus 1 equals 0, that is m equals 1, the inequality becomes 0 greater than 0, which is false, so there is no x. Finally, combine the valid cases. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.